Great. So today it's my pleasure to, it's really a true pleasure, to introduce our guest speaker, Reihaneh Irani-Famili. And she comes to us, she had got her bachelor's degree actually in chemical engineering at the University of Tehran, a master's of science in chemical engineering, and an MBA at the University of Calgary in Canada. She then went on to be a process engineer at Worley Parsons, a manager of major initiatives at Devon Energy, vice president of clean energy development, transformation, and other areas at National Grid. And that's where we kind of met you. She even served on the Rist Institute for Sustainability and Energy's advisory board, which we were very grateful for as well. And now she's launched her own, a new company. She's founder and president of Viridi Edge. And this company is, your mission, I believe, is making decarbonization feasible and profitable for other companies or other entities. So I think it's a really exciting space to be in right now. So I want to ask you to join me in welcoming Ms. Irani-Famili and hand it off to you, Reihaneh.
Thank you, Juliet. And we met on a panel. We were talking about permitting and siting, which you'll see as part of these slides. I was working through them. I was going back, thinking about our early conversations. So thank you for being here. For those of you whose this is your senior class, that's great. And for those of you who it isn't, I love the fact that you took time out to meet someone new and learn something new. So well done. So first things first, this is what I'm going to talk about today. And this is going to be a discussion. I would love for us to talk through all of this. So I'm going to pause for questions or comments as we go. I'll touch on my journey and my transition. Then we talk about energy transition and the drivers of that energy transition. And that's my perspective. I just want to make sure that this is one view of that world. And then what are the complications that I have come across and seen on the grounds that, as I call it, I've touched the pipes and I've touched the wires. As I have gone through that journey on the front lines of this transition, what are the complications that I have seen? And then observations of what it takes. And we were joking that it's very simple. It's just a list of things, and if we do them, then we can get it done. But we'll talk about that, and my new venture is really focused on that last one, the growing role of large consumers, energy consumers. And I'll spend a little bit of time, if we get to it, to tell you why I think it's such an important opportunity. I could not have been here and not done this. My citations are not ideal, so I'm not a good role model. Don't use me as an example. But I have put all my sources up front here for you as we go through the charts. Most of them have the citations on them, but you'll see where the information and the data is from. Anyone came here hoping to hear something else or different, or have anything that want me to touch on? No? Okay. Sure, let's see if this works. Okay. Reihaneh's journey. I'm going to talk about energy transition, but I also want to talk about life transition and career transition, because those are all same journeys. So I was born in Iran to a entrepreneurial, very young, in their early 20s, architects, both of them. They met at school, probably around your age, and then soon after they had me. I went to school there, and all of my childhood and getting into early adulthood and deciding what I wanted to do, I thought that I'm going to be changing the world. And that meant different things at different parts of my life. But it became a lot more clear as I was getting close to university that it was about building things. And then it was about solving problems. And it was about energy. And why? At the time, I thought the one thing that everybody uses, and that was like in the height of oil and all the conversations about that, and at the same time, this is like 1990s, as my son would call it, in the 1900s. In the 1900s, this was when the conversation about global warming was coming up, and I thought that there's something there. And so I went into engineering despite my dad wanting me to become an architect like they were and taken on the journey that they have started. And as I was going through that, and I'm just realizing my arrows are not showing, my parents decided that we needed to immigrate and we needed to move. And so, not that I have never thought about it, but it was kind of like that external impetus that I gotta pick up and I gotta move and I gotta make a new life. But the trajectory didn't change. I still wanted to do that. I actually wanted to go to Alaska because I've heard that they're really disturbing the land there, and I wanted to go there and find a different way to produce the oil out of there, and everyone laughed at the time. But I went to Calgary instead. And so I did my master's in thermodynamics, and from there realized that I wanted to go out in the world and work. And this was around the time, and all of you will probably go through these journeys, or some of you, that you're starting to realize, okay, the safety net of the parents are not there. I want to buy my own coffee. I want to pay my rent. I want to have a family. I need to make money. And so how do I do that? And so all of a sudden, that ideal of changing the world, what started to become more profound, or I guess at the time in my world, was how do I make money now? And so I became an engineer. I started to make money. And somewhere along the way, I realized that it was really important for me, the role that people played, because I still believed that we needed to make a sustainable energy future, and I wanted to be a part of that. But I started to see that you can't do that without people. You need to mobilize people. You need to bring them along. You need to, and then all of a sudden, developing people became important to me. And that was around the time that I raised my hands for a lot of projects that were corporate projects at my work, and got involved in that. And a manager at the time, the company that I worked in, brought me a strategy book and said, read this, I think you should go do an MBA. And I've never thought about an MBA. That was never in the trajectory. I felt a failure because I haven't done a PhD anyway, so I read the book and I loved it. And that was, I guess, the start of me only reading business books, and for joy, not for anything else. So I went and I did an MBA. I couldn't leave my job and do an MBA. So I did it as part-time while I was working. And after that, I went and did management consulting, which, as I had to explain it to my dad, is like about being a doctor, but for an organization, which he never understood. And realized that I really loved the impact that I could make working in energy companies. And so that made a shift for me going into management in oil and gas company at the time, Devon Energy, and starting to establish what we call sustaining capital, the ways that you can operate these facilities in the most efficient way. And so I did that, and in that process, what became important to me, in addition to the developing the people and the making the money, was really to having an impact. I was away from this ideal of I can change the world, but I came to understand that I might not be able to change the world, but I can have an impact. And so as you see this, as I grow in my career, my values, my priorities, my purpose starts to reshape. At around that time, I got a call and got convinced that, rightly so, that the utilities were going through a tremendous amount of disruption. And for the energy system to continue to work, we needed to make a change in the utility world. So up to this point, I'm in upstream producing energy, producing molecules. Now this is about distributing them. And it's also about electrons. So that was a big transition. So I thought about it a lot. It was an opportunity that we did not take lightly, but it would mean a major move. And so as a family, we decided to do that, and we made that switch. That, again, had an external factor of somebody else, a big move. So that was a transition. I had a fantastic time doing that, building people, building teams, building organizations, having had opportunities to be a part of things like the COP. I don't know if you know about COP, but that's the Conference of the Parties where they talk about climate change. Being able to develop major projects and programs. Brilliant part that I felt that I can make an impact. I still believe that we did all that we could to make positive impact. I could develop people and teams, and I could support my family. And so a point came where things around me started changing and shifting, and I realized that my journey was not aligned where what I had two choices. I could do what I was told and then give up on the impact, or I could continue to believe that these three things are still important to me and I want to drive them, and I had to make a change. This was the first time in my life and my career that that change was something internally motivated and driven. And that's not that long ago. That's it's 6 months ago that I made that switch. And so that was a me move to become a climate entrepreneur. And I thought that is the way that I can do all of those things that I wanted to do. And I can, on top of that, build an organization that I think the future corporate needs to look like. Time will tell. These are, I think this changing the world, I need to move another bar of that on the other side. I think I'm starting to believe that maybe that is possible, but time will tell, and I will never go back and change anything about the journey, because it's really about all of those moments and all of those learnings and all of those people that you meet along the way that make you who you are. So let me pause there. Any questions, thoughts, reflections before I move on? Go ahead.
Where do you think this is kind of a hypothetical question, but given that book on business that first time, where do you think
No, it wasn't a thought. I don't think that without her push, Leanne, and I still, once in a while I call her, that really changed my path. Something that I really think about for my son is exposure and knowing what is possible. Up to that point, and maybe even beyond that, I didn't know what I could do and what was possible. I had a very narrow view of a box that I could live in. And I think that was one of the first times or moments that I got pushed to think that there are other things that are possible. Okay. So that's Reihaneh's transitions. Why energy? And I'm not going to spend a lot of time on this, but energy, you'll hear me, my teams are tired of me hearing me saying this, but energy is a fabric of a society. Close your eyes, imagine a day without energy, and then shout out what you see. What's there?
Cold.
Cold and dark. What did you say?
Oh, yeah, just like
Nothing.
nothing.
So energy is really a fabric of the society and something that we often take for granted because none of us remember a day from the day we were born that we flipped a switch and the light didn't come on. It's odd, like something bad must have happened if that happens. And so also as a world, the more energy that a country uses per capita, the higher GDP they have. So energy is a fabric of a society. It's also a driver of the economy. 7.8 million jobs in the US, and that number is growing with the renewables, is tied to energy. That's from DOE. 8% of global GDP are tied to energy. And hundreds of billions of dollars, I think 270 billion of investment in the US last year was in renewable energy, and another 190 million or so in energy. So huge, huge, huge driver. And energy has been that way for a very long time. So from muscle to coal to oil and so on. How many of you are familiar with like the industrial revolutions, like the Industrial Revolution 1, 2, 3, 4? Yeah. So industrial revolutions, if you overlay it on the growth of the energy, you'll see that the energy sources were also always a fuel, and the transitions in that fuel source has driven a lot of the industrial revolution. So pre-industrial society, a lot of fire and muscle and farming. Then you get into the Industrial Revolution 1.0, which was when engines were created. And what drove a lot of that, these steam engines, was coal. So you'll see the growth of coal as an industry and as an energy source driving that. Then comes the oil. And so the finding of the oil, that coincided with the mass production of everything, including cars, which further fueled oil, and electricity started to be generated. And so Then you go from there and you get into now a faster pace of these revolutions happening. Industrial Revolution 3.0, the electronics and automation really fueled that. And what do you see from here? What fueled that electronics and automation? Now it's electrons. Now every step from here, you go from the coal to oil, molecules, now to electrons. So the energy transition and the transition of our society is something that I think it's linked. And it's inevitable that we are going to go through transitions. However, there are some really important drivers of that transition and the pace of that transition. What do you think those are? What's driving this energy transition?
Pollution.
Mm-hmm. What else?
New industrial revolution. They use a different technique for how they're fueling, like oil, you have cars,
Yep.
coal, just burns with steam is. So I guess electrons would be like nuclear gas.
Brilliant. One more, and you've covered my other slide. So these are the drivers, in my view, again. The addressing the climate change or the pollution, that is a big driver on why we need to transition this molecule to electron. The electricity load, what you talked about, there are different ways, whether it's electrification of fleet or vehicles and transport and heating. And then the other one is just the advancement in the technology. This is actually, I found this really interesting. I had a different chart and I changed it this morning to this one because this is how fast terawatts of these energy sources have been created. So you'll see hydro took 40 years to get where it is, coal, gas, nuclear. Nuclear took about 20 years to get to its peak. And then you see solar and wind, and they're moving really quickly. Now, solar and wind are not new technologies. Like I think solar is 1950s. But becoming an energy source, that has been happening really quickly. 2 minutes, this is my favorite stat. 2 minutes of the energy of the sun that reaches the earth. 2 minutes. If we captured all of it, that could feed the whole humanity for 1 year. So the solar potential is massive. And I think that's why you're seeing, plus the technology is pretty simple and repetitive and repeatable, and that you're seeing, but we're nowhere close to taking full advantage of it. So addressing climate change, I won't spend a ton of time. You all know this a lot better than me. But this is not something that this is not a theory in the future. It is here, it has happened. This chart is the number of disasters, the natural disasters since the 1900s. And I have lived that peak. We're still living through it. So I was the Vice President of Emergency Planning and Business Continuity. In 1 year, we responded to 34 storms. Out of those 34 storms, 3 of them hit the top 10 of historical events that we have managed as a company. Out of those 3 today, 3 years later, only 1 remains on the top 10 list. So that's something that is here and it's happening, and it's responding to it, which 78% of boards Still, forget about the rhetoric you hear on the news, 78% of the board of directors in the world still call that as their number one concern in the governance of an organization. So it's addressing it and adapting to it both are really important. And these events are happening more often, and they're more extreme, and all over the world. Last year, the year before, at a COP, I sat next to a representative from Africa, and she said, for you, energy transition is about building an economy and doing good for the world. For us, it's a matter of survival. She said that for them, access to electricity, forget about where it comes from, access to electricity, because of heat and what I did not expect, because they need to pump the water, because the extreme rain events that they have means a lot of runaway. It makes it impossible to live in the towns and villages that she was from. And so the other interesting thing, a mile and a half away from a major transmission line, a village could not get electricity. So these are not just impacting us, it's impacting the world. What is positive about it? And I know, even in my household, not everyone agrees with me. We have made progress internationally. If you look at Kyoto Protocol, it was all about let's all agree that we need to do something about it. You get to the Paris Agreement, let's go create targets and do something about it. Then you come to the recent years, and it's about tactics. 3 times the renewables, 2 times the energy efficiency. It's past, in many parts of this world, it's past the conversation about whether or not we should do something about it. It's about how much and how fast, and what that means in the global supply chain. Talk about load. So look at this load. This is the load curve. Up until 2020, you'll see that we've done a really great job of energy efficiency, both because of carbon reduction as well as cost. And that has meant that we have reduced our need for electricity. This is in the US. Actually, NERC, so North America. Includes Canada, does not include Mexico. You come to 2020 and beyond, and that's where the conversation about electrification of transport, electrification of heating, advanced manufacturing starts increasing the load. So 2 interesting observations in that load increase. What are those? And don't read the notes. So 1, the slope, it's an exponential growth. And 2, you'll see your gray, which is your summer peak, which has historically been the peaking for electricity, that's flipping. And your system is becoming winter peaking. Why does it matter? Those are good reasons for why more, for sure. Yeah. Solar is more available in the summer. That's good observation, but that's not what's behind this. I think the flip between the cold and the summer and the winter is because of how many electrons we use, not accounting for the solar behind the meter generation. But yeah, no, but why it matters is the system that was created, the capacity, it was all created based on this idea that in the summer you were going to, so for example, dams, they generate less in the winter because the water levels are lower than in the summer. So you have less hydro capacity in the winter. So when you see that flip, your full system of what do you have available at what time, what kind of resources, you need to make different decisions for that. And so these things are happening for the first time. I'm not going to go through these, but I just wanted you to see there is a lot of conversation about electric vehicles, but globally, electrification of transport is on the rise. And that is not driven solely by climate. It is driven because the maintenance cost of electric vehicles are lower. Electric vehicles, Chinese electric vehicles, are becoming massively less expensive than any other car because they have less components. And there are policies across the globe that has driven manufacturers to do more electric cars. So that is happening. And so one of the things that I said in as a utility executive is what I worry about is not me enabling or pushing for electrification of vehicle. You might remember me saying this. What I worry about is people are already down that path. Do we have a system that allows them to charge? And so these are those kind of drivers of the transition, the momentum behind the transition that's going. Manufacturing boom, I thought this was really, really insightful. So we have spent $129 billion in power projects, power type infrastructure projects, 235 in manufacturing. Manufacturing investment is overtaking energy investments, which is fantastic news because we do need to bring manufacturing back, but it's also driving load, but is a bad. Okay, and then if you want a perfect storm, you got the demand, you got the policy, the global reasons behind it, and the supply, the renewables are getting a lot cheaper. I put these numbers here. First, this chart didn't go to 2023. But secondly, it's important to see the range because depending on where you are, the numbers can really vary. But directionally, they're all the same. Onshore wind, solar, those prices have dropped and are continuing to drop. So they're becoming real competition as an energy source. That's going to drive, put everything else aside, that's going to drive this transition towards more renewables. And we want it to happen a lot faster, and we want it to happen a lot more, but that's the direction that's going. So we've got the supply, we've got the demand, and we've got the needs. So why isn't it happening yesterday? I had it in my plans to ask you why you think it's not happening yesterday, but I switched the slide. But let me pause there. Why do you think it's not happening? Or do you think it's happening?
I mean, if you look at nuclear energy, there's been multiple accidents, people don't use it. But like logically, if the first caveman burned his house down and still used fire, if that makes sense. But like, then you have Chernobyl and like everyone's like, oh, it's scary. So just like again, like, everyone's scared of it, but it's like really good, really, really good. So again, like,
That's great. Public perception. That's a really valid point. Yeah.
I guess so this is like a niche example of public perception, but here in Lowell, I know a lot of people have like been scammed by like these like affordable energy providers, and now they're really skeptical of these real
That's a really important point that you bring up, and that goes back to consumers can benefit from this transition because that they have the power to generate, they have the power to control load and provide flexibility. However, the intermediaries, because the market doesn't exist, because the knowledge doesn't exist, because the policies are not going that, the intermediaries right now as a scamming, in the future and in some other markets as an intermediary are the ones that are benefiting from it. So you will always have that, but that's where I think there's real opportunity for the end consumer to be more energy aware and be more energy savvy, and for voices to speak on their behalf so they can benefit from this transition. Really, really good and important point. So let me touch on a few of these complications. First, aging infrastructure. About 5%, so add those things up, that's 15, 25, 30, 30% of transformers, like those little round things that you see, not little, but round things that you see on the street or in the substations, those are over 40 years old in the US. That's a really old infrastructure. I have seen Edison installed power lines and towers in New York. We still have them. They're on the system. And that's not, we're not alone in that, although we're one of the unique ones. 50% of our infrastructure, and in New England it's a lot larger than that, are over that 25-year mark. So old and aging infrastructure. Now you're adding load to it, you're adding climate adaptation and climate issues to it. It's difficult. This is climate. That's snow in Florida. Who thought? I never thought I'll see snow in Florida, but that's snow in Florida. And that's fire in Los Angeles, which I have 2 friends that lost their homes. It's real. It's there. That's actually me. We were taking stock of the tree damage. When you have outages, I think Eversource says 90% of their storm outages are tree related. We were, I think, a little over 70% tree related, but that's because majority of our infrastructure is above ground, so it's exposed to the climate. You have this climate that is changing and becoming harsher and more extreme, and now you have an exposed infrastructure that's old and aging. What it takes to respond to those, and this is the unsung heroes of this energy system, that's where storm workers sleep for days to be able to bring customers back. That one was in Rhode Island, and it's actually one of the brand new ones that at the time there was a new vendor that we brought, so I went in and took pictures. But that's where they sleep, that's where they eat, that's where they take shower to bring power back to us during these storm events. This one, and I don't know if the video is going to work, it's not really, I just wanted you to see the pain. When a pole comes down, you need to put it back. Now, this is a laydown area, so the poles are stored here. This is going to go for, I think, 3-4 minutes. And in 3-4 minutes, they're not even able to move this and put it on a truck that's taking it to the site that's replacing the pole. So every one of these poles, as they come down, they take, after it's on a truck and arrives there, anywhere between 3 to 6 hours to be replaced. That's how complicated these climate events are for the system. What does that do? The first time I saw it, the NERC, the North American Reliability Council, presented this, and it scared me. Because we're not used to seeing elevated risks and high risk. This is risk of reliability. Do you know what reliability of the energy system is? It's the hours that you could lose power. And so we don't want to have, we don't want to have any outages, right? 99% reliability. Normal risk is low likelihood of electricity supply shortfall, so we don't have enough electricity to feed the system. Elevated risk, only extreme conditions. High risk, even at normal peaks, this could happen. So for many years, this picture was all in the normal risk. And if you had an elevated risk, that became newsworthy. Now, MISO, which is one of the electric regions, is living in a high-risk area. Why? Because it doesn't have enough supply, their fleet of generation is retiring, the queues and the building of the infrastructure is taking long. So the reliability of our system is becoming more and more at risk. And all of that would add to the cost. And the cost of energy is increasing and continues to increase. I think New England has one of the highest, I think Massachusetts is in the top 3, energy costs, electricity costs in the whole country. Residential prices average across US 17 cents a kilowatt hour. Here in New England, 30 cents a kilowatt hour. So that's real impact to the wallet of the consumer and a real dent in the economy. We need to do something. Now, I could probably talk for hours about this, but I'll try to make it really quick. The energy system, so all of those complications add to it that the energy system is changing, and that's the transition we talked about. For many, many years, energy system has been a one-way highway. I generate the car, electricity, the electron, sit in it, sit in the highway, get to the customer's house, done. That's not the case anymore, because with renewables, the generation goes where the sun shines and when the wind blows. So it's not where you design it to be, it's where the resources are going to be. So they're farther at scale, they're farther from the, they're also more intermittent, so you need firming resources. And firming resources is when you, the storage, for example. So the duration that you take the energy and then you store it, and then, so you need that. You also have a lot more opportunity behind the meter as a consumer to generate, to store, and to potentially, I call play in the market, give to the market when they need it, of energy. So your grid is no longer a one-way highway, it's a platform. It's a platform that needs to allow everybody to play. It doesn't today, everyone's trying, but that's where it's going. And for it to work, that overlay of grid as a platform has to happen. And then with it comes the rise of the prosumer. And do you know what prosumers are? So go ahead. That's right. That they both consume and produce. So if before you were only a consumer of electrons, tomorrow, if you're on vacation, if you have a car and a solar, you could be a producer of electrons that can supply your neighbor's electricity. So it's a very different relationship. I want to touch on one other thing. How are we doing for time? Okay. Okay. So we can come back to this. I just wanted to touch on the complexity of, if we have time, I'll talk about this. But you also have aging systems and processes in the organizations. These are pictures. When I arrived, one of my first tasks was the transformation of our gas field workers' systems. That's what I saw. That's where the data was, and that's what they had. Now, majority of them on the side had their own personal phones that were like normal phones and not flip phones, smartphones, that they used half the time, but that was the infrastructure that was given to them. Why? Part of it is the regulatory regime. So how companies are paid for the services that they provide. So they have been incentivized to sweat the assets. So take what you have and use it as much as you can. And do not invest more than what is absolutely necessary in it. So you do that for 20-some years, that's what you're going to get. So you have all this changing energy system, you have all the complications we talked about, and you have this as an infrastructure for your people to work in. And then this is my ultimate, like honestly, one of the biggest things. I think we have lost the art of building big things. We have completely lost that art. And the founding fathers of the United States, the people that went and built Canada, they built from nothing. And somehow along the way, we completely lost the ability to build big things. This chart, I just wanted to show you that in the last 10 years, we have built less than what we have built in 1 year in 2013. Why is that? Partly we talked about community engagement. Partly we talked about interconnection queues and the complexities of making those studies and decisions and who can access the grid and who not. Talked about permitting and siting, the complexity of a supply chain that is so global and interconnected, and then the management and governance of projects and the skill of project management. That is not there at a scale that it needs to be. And so that's something that really foundational that we need to change, and it starts in these rooms. That's a skill that you need to develop. I often told my teams, if you can organize a birthday party, you can be a project manager. Just have to care as much. But it takes focus. All right, so we're almost out of time. Let's talk about what it takes. So you heard everything that I said. What do you think it takes to make this transition happen? Yep. What does it take? Yep. Yeah.
Obviously, it just takes like investment and input, so like the government like follows it. Obviously, there's like a job market here, so it's like if the government steps in and says, hey, like back when they used to have like those large government workforces to create jobs, it needed something like that, I guess.
Yeah. Policy, regulations, absolutely. I would say people. You need talent. Yep. Exactly. That's where it's fed. And I would say it's way more than power engineers. A lot of times people talk about power engineers and wind turbine designers. It's a lot more than that. I think what you need is project controllers and project engineers and yes, the power engineers, but also the contract managers and the logistics and the supply chain. It takes so much. Transmission lines. There is no transition without transmission. That needs to happen. And when I say transmission line, I'm not talking about a transmission line from here to there. I'm talking about regional, interregional, interties that allows us to optimize the whole energy system between Canada, New York, Massachusetts. Take it a stretch, go all the way to the islands that are farther away from us. If we have the interties, we can optimize, because it might be windy over there when it's not blowing here. It might be sunny here when it's windy over there. We could have nuclear here, nuclear there. So if the more that we can share these resources, the less we need to, each of us need to build on our own. Investments, and then I said people, but I added this here because we need change-ready, adaptable workforce, and we need change leaders. We need leaders that can mobilize. We need leaders that can communicate. We need leaders that can convince. And we need a workforce that can work with that. And so that's really important. And innovation, we'll always need innovation. And I think in this space, more than ever now, needs to be innovation of process, of technology, of all that. And I would say it also takes collaboration. And that's the other thing that I don't know why, but I feel like we used to know how to collaborate a lot better between communities and companies, between neighbors. We need to get back to that. We need to find a way to collaborate more, to find solutions together, to develop those solutions and put them forward. And I saw that working when we were developing a project that unfortunately got put on hold for an intertie with Canada. The communities along the route came together, they supported it. The companies came together and talked about how we can be complementary. And it was a fantastic opportunity. I saw what collaboration can do. Let me pause there. I know this is the end of your class. Happy to answer any questions you might have here or later.
I guess when it comes to energy transition, how much impact is it having right now? Like, for example, you have emissions went to another year. For example, executive orders to halt like future wind leases. Does that include solar too?
No,
I don't remember.
no, just stop sharing.
Or like the pull out of the Paris Climate Accord, or
So that was the one thing, and this is a glass half full maybe view of the world, I don't know, but that's why I started by talking about the energy transition as something that is happening not because of one thing. It's not because of the climate. It's because of many things. It's because of cost, access, load. You see Texas oil hub, all this drill, baby, drill, it benefits Texas. Texas is one of the fastest growing renewable states now.
But its emissions are not going down.
No, their emissions are not going down, but the energy,
That's a little bit tricky, right? It's like, yeah, anyway.
no, I agree, but the energy transition,
Yeah.
the transition of molecules to electrons, those are happening. Now, can this hinder the pace? Yes. Can it put offshore wind development back? Yes. But the one thing that I worry about, I think we as a country will fall behind in the race in the energy transition. And not just the carbon reduction, but the generation, lower cost of generation, wider access to generation. There are countries like China, India, they are going a lot faster than we are. And if we take our foot off the pedal, we would be losing in this race to energy transition. We have an opportunity to build an economy and save our planet. It's a win-win. I don't know why we wouldn't seize this moment. You were going to say something.
No.
Yes. What were you thinking?
No, it's just, you said, I don't know why we would seize this moment, and it's come down to politics at this point. There's a lot to be said there. Yeah, not sure I want to see.
Yeah, there are recent data. I don't know if people are familiar with the Yale program on climate change communication, but they do like these surveys of Americans like very frequently. And they did one in December, so it's very interesting. And even a majority of both parties support renewable energy and controls on greenhouse gases, but that doesn't mean the leaders do. And so, I mean, there is no doubt that this change in administration is having a massive impact. It is going to have an impact. So we need to stand up for what they actually support. Otherwise,
Yeah, we got to keep going.
I was just curious, you had mentioned a couple slides back, and also in the slideshow we had to do for homework, you had mentioned, like, you guys are expecting higher winter peaks in the future.
Mm-hmm.
And I don't know how far in the future you guys are predicting that, but, like, I was looking it up, and climatologists are like, oh, it's been going around for a while now, that winter is going to be warmer in the future, and stuff like that. So why do you guys think it's going to be?
That's a really good question. So the switch to a winter peaking system is because heating up to this point has been molecule based. So majority of heating has been either oil or natural gas. That is becoming more and more electricity driven, which is a new load that wasn't on the system before. So that's what's making that switch. But good point. And I want to, thank you for bringing that up. The slide deck that you saw, the ISO New England, that's the New England view of a lot of the things that I talked about. As I was thinking about what to give you, I thought that's a good succinct view of how the New England energy system is changing. But happy to answer any questions that you have on it. That was a good one, thank you. Okay.